Okay, this information in the video is going to be supplemental to the information in 411 and 412. We're going to look at reverse engineering motion and how to translate motion. So all this information is stuff that I expect you to read, and I'm going to break down some of the instructions hopefully into simpler or shorter terms at least. But as a reference, we're going to be using these dimension drawings right here. And we're going to just look at this pear-shaped cam for right now. Okay. So I've got a fusion drawing open. These drawings here are in inches. Okay, so I'm going to change the document settings into inches. By default, it's millimeters. So now we're in inches. Okay. And then going back to here in our directions, it's telling us to create a couple of parametric dimensions or parametric parameters to start with. Parametric modeling means we have user-defined parameters that you can use to make your models grow and shrink together. So for example, if you go to the store and try on multiple pairs of shoes, they didn't do a brand new design for every size of shoe. They use parametric modeling to scale shoes up and down as needed for people that need different sizes. Okay, so that's one use of parametric modeling. Okay, so it's telling us to go ahead and add in some user parameters, and in Fusion that's going to be under this menu. And this f of x is telling you that you can put in mathematical functions in here. Okay. So as you create models and sketches, the parameters will be populated in this table, in this spreadsheet, but I'm going to add a couple of user-defined ones. Okay, so the first one is going to be nominal diameter, and that's referencing those drawings again. It's going to be 2.5 inches. Don't mind my poor typing, please. Okay, and then we're going to add in a second one. I think right here, axle diameter, 1/4 inch. These terms will start to make more sense later. Okay, so these things are predefined. So if I look back, I'll go to these drawings right here. These dimensions are not telling me a specific dimension, but rather they're going to reference the nominal diameter that I already defined. So the radius of this arc is the nominal diameter divided by 2. Okay, so I'm going to start to draw this cam right here. And this part right here, I'm going to start by drawing the circle. So in a dimension on a drawing, an arc is always dimensioned by radius, and a circle is always dimensioned by diameter. This is an arc, but it's going to begin as a full circle. So even though the radius of this is d over 2, it's going to wind up being d because diameter is 2 times radius. Okay. So if I start with the circle right here, I could type in a number, or if I start typing d for my user-defined dimensions, these are ones that are already in that table. So this is going to be nominal diameter. Okay. And this is showing f of x, 2.5. That means that's the output of the function right there. Okay. The top of this radius is nominal diameter divided by 8. And since I'm going to make a circle, I'm going to start, instead of radius, I'm going to start with diameter. So instead of d over 8, I'm going to have d over 4, just because diameter is 2 times radius. Okay, so I'm just going to kind of put it in a spot up here, guesstimate a little bit. All right, when I hit D, this is already searching through that table. So it's going to be nominal diameter slash for divided by 4. Okay, so f of x is 0.625. So that means it took 2.5 divided by 4. That's the output of a function. Okay. So now it tells me the distance between the centers of these is d over 2. All right, so I'm going to add in a dimension between these two centers. That is going to be d divided by 2. Okay. Let's look back at the drawing. So now I have these lines kind of coming here. So what I'm going to do is I'm just going to kind of freehand some lines right here. Okay. And now I'm going to make these lines tangent to these circles. Okay. Tangent constraint, I want to make this line tangent to that circle. Negative. Why did that happen? Okay. So we want to fix this circle so it can't move. Now it's fixed. Now that one's fixed. Now if I put in this tangent constraint, the part that I want to move will move. Tangent to there. I also want to make this tangent to there. I want to make this line tangent to that circle. That, I'm going to delete that constraint right there. That was in the way. I think I had one too many clicks. So let's get rid of that line right there. Okay. I just want a single line right there. This line is going to be tangent to that circle. And it's also going to be tangent to this circle. Okay. So, kind of looks like a cam. All right. So now we're going to use the trim command. I'm going to trim out parts that aren't needed. Trim that. Trim that. Trim. Trim. Trim there. Okay. Done trimming. So now this looks like that cam right there. All right, I can finish that sketch. Actually, nope, not done yet. Let's go back into this sketch. Because we also need this little hole right here. So, at the center right here, and this circle is going to be the axle diameter right there. Okay. Now I can finish that sketch. And this tells us how thick are these cams. It doesn't tell us on here. I think it's in here in the instructions. So right now I'm going to just make this a 1/4 inch thick. Okay. So this is a pair cam that's been parametrically modeled. Okay. So if I go back to these parameters right here, try to get it where I can look at both at the same time. So if I go in here and say I want to modify this to 2.25, well, my whole model changed together. I didn't have to go back and edit sketches, edit extrusions, If this cam was producing a certain displacement of linear motion and I decided it was too big, I could just make this smaller. Or if I wanted it to produce more displacement, I could go make it bigger. Or if I decided I needed a different size rod or different size shaft for it to ride on, like I need a bigger one, I can modify that. The hole just got bigger. Okay. When you start to develop more advanced models, it gives you a lot more control when you use parametric parameters.